So why we are using this type of algorithm or searching algorithm? Because to find the optimal solution. Optimal solution because at the every state path we have a least cost chosen. Which is the optimal solution? Optimal solution where we have a lowest cost and we are reaching to the goal state. That is called as optimal solution. Hello everyone, welcome to the one more session on artificial intelligence and applications for 6th semester B.Ca students. Myself Indu J, Faculty of Computer Science Departments, Vidhyaashram First Aid College, the Temple of Excellence, MYSURU. In this session, we are going to continue the discussion on problem solving searching, that is of the second unit. Last session, we have discussed 3 different uninformed search algorithm. In today's class, we are discussing 3 more uninformed search algorithms. Let us start what are the different uninformed search algorithms we have in this session. First one is we are discussing is uniform cost search algorithm. As name itself indicate, we have a cost for the graph or the tree. How the cost is decided to traverse from one node to the other node, how much cost it will take, that is called as cost of the graph or the cost of the node. To traverse from node A to B, it's taking 2 cost. From traverse node A to C, it's taking cost as 3. That is called as cost of the node. So why we are using this type of algorithm or searching algorithm? Because to find the optimal solution. Which is the optimal solution? Optimal solution where we have a lowest cost and we are reaching to the goal state. That is called as optimal solution. So searching algorithm used for traversing the weighted tree or the graph. Whenever we are giving such cost, this type of tree is called as weighted tree or the weighted graph. Comes into the play when the different cost is available for each edges. When we can apply such algorithm, when we have a cost for each edges. The goal of the uniform search algorithm is to find what? Find the goal node with the lowest cumulative cost, which is optimal solution. We consider the lowest cumulative cost as an optimal solution because we are reaching the from start node to the goal node with a minimum cost. That is what we call it as lowest cumulative cost. Cumulative means from reaching A to B, B to G. All costs should be less. 3 plus 5. E should be 5 and if it is a 4, you are reaching at the 7. If you are following this path, you are reaching at the cost 7. If you are following this path, you are reaching at the cost 5. So this is a cumulative cost. Cumulative means 2 plus 3. Combining all the edges of the nodes to reach the goal node. Okay. Uniform cost search algorithm is implemented by using what? Priority queue. We are using the data structure to implement. We are using the queue data structure, that to the priority queue. Why priority queue? Priority is given to the lowest cost first. That's why we are calling it as priority queue. It gives the maximum priority to the lowest cumulative cost. The uniform cost search is equivalent to BFS algorithm if the path of the cost of all the edges are same. If it is all the edges having the same cost 3, 3 and 3, then it will follow the BFS algorithm. Next, let us see, understand this uniform cost search algorithm with an example. Here we have a start node. S is a start node. So we have to reach to the goal node. So each edges of the graph is given with the weights or the cost. Each edge of the graph is given with the weights or the cost. So if I follow this path, I'll check I have to reach from the node S. I can reach to the node A or I can reach to the node B. From S, I can reach to the node A or from S, I can reach to the node B. Here we have to check what is the cost of reaching from S to A and what is the cost of reaching from S to B. What is the cost of reaching from S to A is 1. Cost of reaching from S to B is 4, right? So which is the lowest here? We select that path. We select this particular path. Okay, now where exactly we are in? We are in the node A. Again, from node A, we have to either reach to the node C or we can reach to the node D. From first path is S to A. Now, from I'll take it as SA. From SA, where I can reach to the C, or from SA I can reach to the node D. Now again we have to check what is the cost of reaching to the node C and what is the cost of reaching to the node D. What is the cost of reaching to the node C? That is 3. What is the cost of reaching to the node D? Is 2. Which is a smaller one? This is the lowest one. It will select this. Now where exactly we are standing? We are standing at the state S, A and D. We have traversed the 3 nodes here, S, A and D. Now from D, where I can reach? From D I can either to reach F, or from D I can either reach to the goal state, that is G. So what is the cost of reaching to the goal state? That is 3. If we are reaching to the F also, we cannot consider, because from F we are not reaching to the any goal state. So directly we are reaching to the goal state at the cost of 3. So what is the cost for reaching the goal state? 3. Now we can cumulatively add these values. What is these values? From S to A, 1. From A to D, 2. From D to G is 3. What is the cost I am getting? Total cost is 6. So either the way I can reach to the goal state. Here also have a goal state, here also have a goal state, right? So if I take this path from S to A to C, C to E and then to the goal, what is the cost? I am getting it as 1 plus 3 plus 5 plus 5. So cost is of 14. So which is a larger value. So we cannot consider, if we have more than one solution auto, we have to consider the minimal cost what we are searching for. So that what is called as optimal solution we get. Next, let us see the advantage and disadvantage of uniform cost search. As we are reaching, we are getting the optimal solution. That is a major advantage what we have. Uniform cost search finds the optimal solution because at the every state path we have a least cost chosen. So that is the greatest advantage what we have in a uniform cost search. What is the disadvantage what we have in this particular searching algorithm is that it does not care about the number of steps involved. It only concentrates on the cost, not about the steps what has to follow. Does not care about the number of steps involved. Due to which the algorithm is stuck into the infinite loop. It keep on repeating the number of steps, so it will end up to the infinite loop. This is a major disadvantage what we have in a uniform cost search algorithm. So next, continuing with the one more type of the searching algorithm is iterative deepening depth first search. This is one more variation of depth first search we can say. We have already discussed what is DFS. This is one more variation of depth first search. We have discussed depth first search and depth limit search also, right? So we are imbibing some of the modification for these algorithms and we are creating one more algorithm called as iterative deepening depth first search. Let us see what does this algorithm do. It's a combination of DFS and the BFS algorithm. It either go to the depth or either it will traverse to the siblings or towards the width of the tree. This algorithm finds out the best depth limit and does by gradually increasing the limit until the goal is found. It will limit, as we have done in the DLS depth limit search, it will limit the search for the particular level of the tree. As we are not finding the goal within that particular limit, it will gradually increase the limit of searching in the tree. The iterative search algorithm is useful for uninformed search when the search space is very large. When the search space is very large, we are implementing this type of algorithm. This algorithm combines the benefits of BFS and also the benefit of DFS. What is the benefit of BFS? it will give the fast search result. What is the benefit of DFS? It will is a memory efficient. So it combines both. It will give the result fast as well as consumes less memory. That is the advantage of using the iterative deepening depth first search algorithm. Let us have an example for this. Here you can see one particular tree. In this particular tree, first iteration will be done, or first limitation is given to the level 0. We are checking whether the first node is our goal node or not. If the first node is not the goal node, we increase the limit of the search to the level 1. Okay, here it will search whether the goal node is present or not in the level 1. If it is not present, then it will increase the limit of the search to the level 2. Right. So here in the level 2, we have more number of the nodes. So probability of getting the goal node is a bit high. So here what we are doing, D, E, F and G, we are getting the goal node here. So it will stop the execution then and there when we are receiving the goal node. It will don't extend the limit to the next level. So what exactly we are doing? We are extending the limit as when we require. That is what is given. Tree structure is showing the iterative deepening depth first search algorithm. In the first iteration, what we are doing? We are checking only with the root node whether the stat node is our goal node or not. If the stat node is not our goal node, we are extending the limit of search to the second iteration. In the second iteration, what it comes from the A to B and A to C. Again, it will search in the level 2. So, the path is from A, B and C. So, it will search here. Now, we are finding the goal node? No. If we are not finding the goal node, again, it will go to the third iteration. Third iteration, we have how many nodes? A, B, D, E, C, F and G. So, in that, we are finding the goal node. Yes, we are finding the goal node. So, we stop the execution, we stop our search exactly there. What is the problem in this here means, each time when we are going for the iteration, first iteration it will start with the root node, second iteration also start with the root node, third iteration also start with the root node. How many times we extend the limit of the searching? Every time we have to start from the root node itself. Okay, if we are going for the fourth iteration, again it has to start from the root node. It has to visit all the nodes of the tree. That is a major disadvantage what we have in the iterative deepening depth first search. In the fourth iteration, the algorithm will find the goal. Here we are finding in the third iteration only here. So we are stopping the execution or searching. What is the advantage and disadvantage of this particular algorithm? It combines the benefits of BFS and DFS algorithm in terms of fast search and in the terms of memory, as we have discussed in the introduction of this. And what is the disadvantage? The main drawback of this algorithm is to repeat all the work from the previous phase. That what we have said. It has to, for each iteration, it has to start from the root node itself. So it consumes more time when we are searching. That is a major disadvantage what we have in the iterative deepening depth first search algorithm. Let us move on to one more algorithm, that is uninformed search algorithm. What we call it as bidirectional search algorithm. As the name itself indicates, we are searching in two direction. It's always better to search more than one direction, right? So it is a most optimal algorithm what we can say. Bidirectional search algorithm runs in a two simulative searches. We are searching, for example, if your pen is lost, you will be searching in one area and your friend will be searching in one more area, right? So the probability of getting the pen is more in the less time. So that's what exactly we are implementing in this algorithm. One form, initial state called as forward searching, and the another from goal node called as backward searching. From where we are starting searching? From start node, as we are doing in the different algorithm. From start node we have to reach to the goal node. So we are start our search from the start node towards the goal node, and here we are having one more searching method where we are backward searching. From the goal node we are trying to reach the start node. That is called as backward searching. Bidirectional search replaces a single search graph with the two small subgraph. What we are doing? We are dividing the graph into two subgraphs, and we are searching from the goal node to the start node, or either we are searching from the start node to the goal node. For example, you can take, you want to go and meet your friend somewhere who is very far actually. So the time consumption is around to reach your friend's house is say around you need 30 minutes. Okay, either if your friend comes to you or you go to your friend, the time is 30 minutes. To reduce the time, you want to meet your friend as soon as possible. What you will do? Okay, you are starting your journey from your home and your friend is starting journey from his home. You both will meet at particular position. Both will travel in the same path and will meet at particular position. That is what exactly we are implementing, we are doing here. From start node we are moving, from the goal node we are moving. At the point where we intersect, we say that we can find the optimal solution there. The one starts the search from the initial vertex and the other starts from the goal vertex, as we have discussed. The search stop when these two graphs intersect each other. When these two graphs will intersect at particular point, then we stop searching. Let us see the example for bidirectional search. It starts traversing from the node 1. They are traversing from the node 1 from the forward direction and start from the goal node. Start traversing from the goal node, that is 16, towards the backward direction. When we are traversing from the forward direction or either the backward direction, we can use BFS or DFS search algorithm to traverse the node from either forward direction or to the backward direction. Any other search algorithm we can move. When we are reaching to the particular intersection point, we stop searching, seeing that they exist on a goal node. So, okay, that's what. From 1, we are moving to the node 4. From node 4, we are moving to the node 8. From node 8, we are moving to the node 9. Here, if you take from node 16, we are moving to the node 12. From node 12, we are moving to the node 10. From node 10, we are moving to the node 9. So, this is a intersection point. Once we reach that particular intersection point, we stop searching, saying that the node is present in given tree. So, what is the advantage and disadvantage of this bidirectional search tree is the advantage. Search is very fast. As I told you, as I just gave you the example, you also moving to the particular location, your friend is also moving to the particular direction. The 30 minutes drive what we have is reduced to 15 minutes and you will be meeting your friend within 15 minutes. That's what the search will be very fast in the bidirectional searching algorithm. Search requires a less memory. It has to store less memory because all the nodes from the forward cannot be stored and all the nodes from the backward we are not storing. We are storing only the intersecting nodes. So that the memory is very less. What is a major disadvantage we have in the bidirectional search is implementation of bidirectional search in the tree is very difficult. Why? Because initially before starting the search you should know what should be the goal node. So the bidirectional search once should know the goal state in advance. As we are dealing with the uninformed search, so getting the information about the goal state is less. So we should know, you should give the information for the algorithm that this should be the goal node of the particular searching. So that's what the disadvantage what we have in the bidirectional search algorithm. Hope all of you clear with all the three types of searching algorithm. One is uniform cost search algorithm and iterative deepening depth first search algorithm, then bidirectional search algorithm. So this completes of 6 types of uninformed searching algorithm. Thank you.